Hello students. So welcome to the last phase of this preparation IIM BSAT, BMSAT. So in this video we are going to see permutations and combinations along with the probability. So if we have to talk about this topic, this is very important topic in case of IPMAT or BBA entrance examinations. You know why? Because this is all related with business. You know, like share market or any events that to happen or not, the event the odds about an event happening or not, this all depends on probability. So there is a more likely to ask this type of questions in your BBA entrance examinations for sure. At least one or two questions will be asked in any type of examination for you. So coming to permutations and combinations, let's start from very basic. What is permutation, what is combination? Students generally confuse about way to use permutation, way to use combination. So it's very easy to remember this. Permutation will take it as P and combination will take it as C. So when to use permutation? It is only for arrangement. Okay, and arranging a thing, I have to take permutation. What is meant by permutation here? I mean the formula NPR. I hope you know about this formula. If not, see here. NPR is nothing but n factorial divided by n minus r factorial. That is NPR. C comes for combination. Combination means, okay, it's not just combination, it is a selection. So how to select? Selection is done through NCR. What is meant by this? N factorial divided by r factorial into n minus r factorial. Okay, so in this way you have to find the ways or find the number of ways to arrange or to select. So simple thing to arrange. For arranging we have to select first and you have to arrange the things. And for combination we have to just select. So generally what do you think? Permutation will be permutation higher or combination higher? Obviously permutation will be having higher number of things because combination will have only few things because it has another factor which is dividing that. Okay, you will come to know all these things when we solve the problems. Okay, let's go into the different models we have to solve here. If there are two kinds of hats, red and blue, and at least 5 of each kind, in how many ways can the hats be put in each of the 5 different boxes? So before going into the question, just understand what he is asking. He is asking the ways to, in how many ways can the hats be put. So we have to see there are 5 different boxes. In each box we have to fill one hat. How many options are there to fill this hat for us? We have 5 hats each. Red hats 5 and blue hats 5. At least 5 of each kind. So that is given. So how many ways are there for us to fill this first box? It is 2 ways. Like that for second box it is 2 ways. And this also 2 ways. Like that we have 2 power 5 ways to fill a box. Okay, so this is the basic problem of permutation and combination. Why we are discussing this, you understand in the next problems, because with this basic thing we will understand the remaining problems also. Okay, okay, fine. Let's discuss here only. Whenever you they say this type of box, one box has to be filled up by two kinds of hats. So how many ways are there for us? We have 2 ways. Like that, if I give 5 digits, for example 6 1 0 3 9, with these digits I have to form 4-digit numbers. How many 4-digit numbers that can be formed with the given 5 digits? So it's just like the previous problem. We have 4 different boxes and I have to fill each box with 1 digit. Okay, so how many ways are there for me to fill this empty box or the empty space? It's nothing but 5, isn't it? No, 5 cannot be the answer because one of the digit is 0. If I fill this box with 0, will my number be 4-digit number? No. So exactly, there are only 4 ways for me to fill this box. Okay, consider these 5 as different types of hats. So I can fill this first box with 4 numbers or 4 digits. Okay, how can this box be filled? I have only, here we have, more number of hats. So I do have many choices to fill each box. But here my options are reducing. Okay, practical application of the above problem. My options are reducing. After filling a number here, for example, 1. Okay, 1 number is chosen. Can I fill that again with this number? Depends on the condition given in the question. If in the question, if he says repetition of digits are not allowed, then you should not select the same number again. I should not select 1 here. So how many ways are there for me to fill that box, the second box? 0. Can I fill that with 0? Yes, here I can fill 0 because after first digit, after this digit, I can fill 0 in any place possible. So I will have again 4 options to fill that box. And coming to the next digit or next space, I do have 0 is taken, 1 is taken. Example, 0 is taken. Let's say, okay, how many ways are there for this? There are 3 ways. For this, there are 2 ways. That means 4 into 4 into 3 into 2. So this is the number of ways that can be filled. Number of 4-digit numbers that can be formed with the given numbers. What if the repetition is allowed? How many ways are there? How many 4-digit numbers are there where can be formed with this 5 digits if repetition is allowed? Again, 4 boxes are there. In how many ways I can fill this box? Even if repetition is allowed, I cannot fill this box with 0, isn't it? So again, I have 4 ways only. Okay, coming to the next one. How many ways are there for me? Repetition is allowed, but that means if I use 1 here, I can use 1 again here. That means again I do have 5 ways. Here, again 5. Here, again 5. That means number of 4-digit numbers are 5 cube into 4. That is the answer for this question. Okay, so the same application. Understand this. If there are 2 kinds of hats here, we do have many hats. So each box can be filled with only 1 hat. That has to be mentioned here. So each different box can be filled in 2 ways. So how many ways that can be these 5 boxes can be filled? It will be 2 power 5. Okay, like that we have to do this problem. Understand this model. Okay. 5. Circular arrangement. In how many ways 4 Indians and 4 Nepalese people be seated around a round table so that no 2 Indians are in adjacent positions? So here there are 2 conditions that 2 types of problems that are mixed here. One is circular arrangement and one is alternate arrangement. How to do this one? So first of all, when we have to fill any circular arrangement, when you have to do circular arrangement, we have to arrange n. In how many ways you can arrange n numbers or n different persons in a circular arrangement? It would be n minus 1 factorial. Remember, here we are arranging persons. Persons means people or persons mean they will be always look different. Okay, if I go in this way or in this way, the arrangement would be different. Whether I would be going in a right hand direction or a clockwise direction or anti-clockwise direction, the differences would be there. Can you, can you imagine a situation where you and your 5 relatives sitting around a circular table? Okay, you can say either to your left side or your right side, people will be different. You can say that it is clockwise and it is anti-clockwise. But what if all look same? That is the condition where all are lookalikes. This cannot be possible for people. It is possible with flowers or let us say beads. Okay, like that. Whenever these beads or flowers are taken, we cannot say which is clockwise direction, which is anti-clockwise direction. So that's why I have to make it half. Okay, in place of lookalikes. that is flowers or beads, right? In case of lookalikes, I have to have this arrangement. Remember that thing. So here, yeah, 4 Indians and 4 Nepalis has to be arranged a round table. For that, first thing we have to do is we have to arrange 4 Nepalis in 4 minus 1 factorial, that is 3 factorial. Fine. After that, how many places do we have to arrange these Indians, so that Indians cannot be sitting together here? Because if I have these 4 places, if I select 4 places among these things, among these 4, I cannot have any Indian to sitting together, right? Fine. So I have 1, 2, 3, 4 places for 4 Indians. So that means I can arrange them in 4 factorial ways. That's it. So I can only say that 3 factorial into 4 factorial will be the different. I can arrange these 4 persons in 4 factorial ways. Only that thing can be possible. So 3 factorial and 4 factorial will be the answer for this problem. But understand, whenever they say, this problem can be asked in different ways. Like only 2 Indians or 2 persons has to be sitting together, or these 2 persons has to be sitting only in this direction. Okay, in that means, for example, if 2 Indians of among these 4 Indians has to be sitting together, that means I have to consider those 2 Indians as one unit and remaining as individual units. That means I do have 3 individual units, 3 persons. I have to consider them as 3 persons. That 3 persons has to be arranged between those 4 places. I do have 4 Nepalis who gave me 4 different positions to make them sit, to make the remaining people sit in that places. So I can use these 3 different places or 3 different persons to select from those 4 places. Okay, so in that way we have to change it. So understand the question. Every question has to be looked differently. Okay, coming to this question. Yes, this is the question I'm talking about. In how many ways can 18 identical white and 16 identical black balls be arranged in a row so that no 2 black balls are together? So here they gave it as row. So I challenge you guys. It's not a challenge. You can answer this question. When this row, this is not row. Why? If it is arranged in a circular way, these balls, make it a garland out of it, ball garland. So if you take it a circular arrangement, what will be the answer? So let me do with a row arrangement. In how many ways 18 identical white and 16 identical black balls be arranged in a row such that no 2 black balls are together? I should not make the black balls sit together. That means I have to arrange the white balls first. So in how many ways I can arrange white balls? First of all, let's arrange white balls. It will be 18. These 18 spaces will give me 19 spaces. Okay, that means out of 19 spaces, I have to select 16. That means out of these 19 spaces, they give me individual spaces where these 2 black balls cannot sit together, cannot be together at any cost. So 19 factor 19C16 will give me a selection of those places into this 18 factorial will give me the number of arrangements in this. So these are the number of ways I can arrange these black balls without sitting, without any 2 black balls together. Okay, let's go to the next model. How many different sums can be formed with the following coins? Okay, fine. When we have to take select coins, taking any combination, 5 plus 1 rupee, 6 rupees, 5 plus 50, 5 rupee 50 paise. You can take any combination. So to take any combination, I will say like how many options are there for me? First thing, 1, 2, 3, 4, 5, 6. Okay, whether it could be 1 paisa or 0.25 paisa, it doesn't matter. How many options are there for me? There are 6. So what if I say 6 is 0, what is meant by this? That means I am not selecting anything from these 6 options. What is meant by 6C1? I am selecting 1 out of 6. In the same way, what about this? What about this? And so on up till 6C6. That means I am taking number of combinations from my given 6 options, right? Like that, I have to find how many options or how many different combinations are available for me. That is nothing but sum of all these things. Yes, you came to know this. This is nothing but binomial expansion. It is not, nothing but looking like a binomial expansion. So can I write this as 2 power 6? Exactly. It's just nothing but a binomial expansion. So 2 power 6 will be its sum. But remember what they said. How many different sums can be formed? This cannot be a sum. I am not selecting anything. Without selecting anything, how can I form a sum? Yes, this cannot be selected. That means one way 6 is 0 is nothing but 1. So that has to be removed from this 2 power 6. 2 power 6 minus 1 will be my answer, will be number of sums that can be formed with this number of coins. Okay, so like this we can have many combinations. Okay, let's go to the next one. Find the number of diagonals and triangles formed in a decagon. Okay, very interesting question. So this type of question can also be designed in a such a way that how many number of shake hands are possible in a meeting. Okay, let's see. So decagon does mean it do have 10 points. Okay, so this decagon can form how many number of diagonals and triangles? Okay, fine. So for a line, can you draw a line? Yes, I have done this. How many points are there in this line? It do have infinite number of points. But my question is not that. How many points do I require to form a straight line? Not a single line, it's a straight line. I need 2 points exactly to form a straight line. So any 2 points can form a straight line? Yes, it can form a straight. Any 2 points can form a straight line. So out of these 10 points, how many points do I need to form one straight line? I need 2 points from this discussion, right? That means out of 10, I need 2. I have to select 2 points in any way possible so that I can form a straight line, right? Fine, that's done. That means a decagon. Okay, try to draw a 10-sided polygon. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So among this decagon, I can form 10C2 lines. That means 10 into 9 by 2. 45 lines are possible. But they are asking number of diagonals. Diagonals means the lines which connect opposite vertices other than the next vertex. Okay, so like this, how many vertices are possible when diagonals are possible in this diagram? Very tough to calculate, right? That means this 10C2 is nothing but, this 45 is nothing but all the lines that can be possible in this decagon. So these all lines will consist of 45. But we are concerned with only diagonals. That is 45 minus how many sides are there? If you remove sides, I get only diagonals. So I do have 10 sides in a decagon. So 45 minus 10 is equal to 35. Diagonals are possible in a decagon. Okay. This question can be asked in a different way. How many shake hands? How many shake hands are possible in a meeting of 10 persons? Same way, 10C2. Here we are asking for shake hands, not straight lines or diagonals. How many shake hands are possible? 45. Okay, not only this same type of question has been asked in your I think GIPMAT exam. How many matches are possible? No, I think Indore only. Okay, you can check this year's Indore or GIPMAT question. It do have this problem. How many matches are possible? How many cricket matches are possible between 7 teams? How many matches are possible? It do have, a match do require only 2 teams to play. That means 7C2 will be the answer for that. but you do have some other criteria to answer that. 7C2 cannot be the, I mean, it's not that simple. You do have other thing. So it is also called as round robin criteria, round robin thing. That means every match, every team has to play a match with other team. Okay, like that. So shake hands, number of diagonals, number of matches. This model is coming from this. Now, can you answer how many triangles are formed in that decagon? Yes, again, for a triangle, I need 3 points. Is that so? Only 3 points? Nothing else? No other condition? Yes, other condition is non-collinear points. Can I form a triangle with this 10 points? Yes, one if and only if these 10 points are not collinear. They are not lying on a same line. Then only we can form a triangle. So yes, in a decagon, we do have, I mean, we should have 10 different points which are not lying on a straight line. If it lies on a straight line, it cannot be a decagon, right? If I have 3 points on a straight line, I cannot say it is a decagon. So decagon do have all points non-collinear. That's why I can form 10C3 triangles with this decagon. Okay. So if you want to calculate 10, 9, 8, 3, 2, it is 120 triangles are possible in a decagon. Okay, you can count. Okay, coming to counting, let's solve this one. How many different triangles are there in the figure shown above? So can I apply permutation combination, that same type of selection here? Just think and answer this. I mean, some kids or some persons has said that I mean, they tried using this number of selections, I mean, number of ways that we can form triangles from the given points. Yeah, let's try that way, that method only. How many points are there here? 1, 2, 3, 4. That means here 8, and remaining points 1, 2, 3. That's it, right? I can see only these points. 8 plus 3, 11 points. So that means 11C3 triangles should be possible, isn't it? But the answer is wrong. This cannot be the answer. Why? Because you cannot count triangles in this method, because we do have 4 collinear points. These points are lying on a straight line. I mean, 2 points can be okay, but this thing cannot be done. Okay, so that's why I cannot use this formula here. Here, the only method you can use is count directly. How many this type of small triangles are there in each square? There are 4. For each triangle, I mean, for each square, there are 3 squares like that. It's 4 3s 12. Coming to a bigger triangle, right angle triangle, every square do have 2 triangles, right? Or no, it do have 4 triangles also. This one, and this is 1, and this is 2, and the other way, 1 and 2. Okay, that means 3 and 4. So 4 into 3, another 12. Along with that, we do have another triangle arrangement like this. Okay, 4 triangles are possible in that way. So in total, 24 plus 4, 28 triangles. I think this is visible. 28 triangles are possible in this diagram. So here I cannot apply this shortcut here, because it is not non-collinear. So whenever you find this type of problems, so we have to find first symmetry. We have to find for only one box. If you can able to count for one box, you can count for every other box. You can just repeat that how many boxes are there, how many same type of arrangement is possible. You can check that one, and you have to mix that up. If I ask how many squares are there, how many squares are possible, you can have to able to see this also. I mean, although it is looking like rhombus, you have to check whether if 2 squares are mixed, if two squares are joined, another square arrangement can be possible. So you have to check for that also. So here we have to use only that symmetry property to count this triangles or rectangles or any type of shape. Okay, so I cannot use permutation combination here. Okay, coming to the next question. 5 balls of different colors are to be placed in 3 different boxes such that any box contains at least 1 ball. What is the maximum number of different ways this which number of ways in which this can be done? Okay, let's see this one. 5 balls of different colors are to be placed in 3 different boxes. Okay, fine. Let us say, let me change this color. There are 3 different boxes. Okay, 3 different boxes, and there are 5 different balls, and such that any box contains at least 1 ball. Okay, so how many ways we can arrange this? Let's see. I can take 3 balls here and each 1 ball, because at least 1 ball has to be given to each box. I should not leave any box empty. 3 1 1 or 1 3 1 or double 1 3. This arrangement is possible. What about next thing? 2 5 are there, right? 2 2 1 or 1 2 2 2 1 2. So this is also possible. So totally 5 balls can be arranged in this way between 3 boxes, right? But here there is a thing which I want to explain. Okay, I will explain later. First, let's count this one. I can just count how many ways are possible like this. In 3 factorial by 2 factorial ways into 3. Alright. So, sorry. 3 factorial by gives me 3. So there are 3 ways possible here, and here 3 ways possible. So how can I select these 3 balls from the 5 different colors? That will be 5C3 for the first thing. And means, I forgot to say this one, that whenever we have to select a perfect condition or a compulsory condition is there, we have to satisfy with multiplication, that is and signifies multiplication here. So next, how many balls are left? If I select 3 balls from 5, there will be only 2. So 2C1 and 1C1. Okay, so this thing has to be repeated for 3 options. So into 3. Okay, you can say take that only. Next one, same thing for this one. 5C2 into 3C2 into 1C1. The same thing, 3 into this thing. So that would be the answer for that. Okay, so whenever you want to arrange different colors of balls, that means you can differ that easily. Which color is going into which box, you can clearly say that. But what if I change the question as same colors? Now the thing changes. Okay, in which way? 5 balls have to be same color, has to be placed in 3 different boxes such that okay, this can also be removed, at least 1, such that any number of ways can be possible. Then you have to take it as 5 ways plus between how many boxes I have to distribute it? 3 boxes. 5 plus 3 minus 1 C3. So this arrangement should be there whenever I use same type of color balls or same type of things to be distributed between R number of things, n plus R minus 1 CR. Okay, so be careful when you answer these type of questions. Look around for this things. Different colors means you can easily arrange, you can easily see the difference between number of ways. Okay, but when there are same colors, you cannot find it. Okay, so you have to use this formula, n plus R minus 1 CR. Okay, let's go to the next one. There are 4 letters and 4 envelopes. In how many ways can wrong choice be made? Okay, so here the question is derangement problem. So derangement problems are very less likely to be asked in your examinations, but yes, you can discuss this model. 4 letters and 4 envelopes. 1 letter has to go to 1 envelope. Okay, it has only 1 right option among these 4 options. Among these 4 questions, 4 envelopes, we do have only one envelope which is right. Okay, so in how many ways it can go? It is only one way, right? And how many ways one right option will be there? It will be only one option. Okay, so for 4 letters, okay, if you go for one letter, it can go to any different envelope. Okay, either you if you have to include every other option, not only just right option, even if you include wrong options, how many options do it have? It do have 4 options for the first letter. What about the next one, second letter? Second letter should have to limit itself for only 3 options, because it do already first one is taken with the first letter, so 3. What about third one? It do have 2. So fourth one, it do have only one option. So like that, we do have 4 factorial ways to these 4 letters to go into different letters. But among them, there is only one way where the correct arrangement is there. So in how many wrong choices can be done? Except that first choice, everything could be wrong. Okay, everything that except that wrong correct choice, every other arrangement is wrong. In how many ways can wrong choice can be made? Yes, wrong choice can be made in different ways. Okay, first letter going wrong, other 3 letters going right. First and second letter going wrong, other 2 options going wrong, going right. Like that, you can arrange in number of ways, 4 factorial ways. Minus 1 will be the right way of arranging. Okay, next let's go to probability. So coming to the probability, I just want to discuss that it is nothing but extension of permutation and combinations. And wherever you found number of ways, if I ask one particular way of arranging or one particular way of selection, what is the probability of that particular way among these number of ways, is nothing but probability. Okay, and here you have to know about these concepts: mutually exclusive events, equally likely events, independent events, and conditional probability. Okay, because students are more likely to get confused with this type of concepts. Mutually exclusive, what does it mean? Mutually exclusive means the 2 events are not at all possible. The chance of happening at a time cannot be possible. For example, if I toss a coin, the chance of getting tail or head will be there, but can I get tail and head at a time? Cannot be possible. Okay, those type of events are called mutually exclusive events. Coming to equally likely events, that means they do have same probability. For example, if I throw a dice, the chance of probability, the probability of getting 1 is 1 by 6, 1 out of 6, and chance of probability of getting 2 is again 1 by 6. So like that, they are equally likely events. What about independent events? Independent events means it cannot influence the next event. The first event cannot influence the next event. For example, again take the example of tossing a coin. In first thing, we said that mutual exclusive event means if you toss a coin, the chance of getting head cannot influence, chance of getting head. If you got head, you cannot get a tail. So these 2 are different. Like that, independent events is nothing but if I toss a coin 2 times, the first result cannot influence the next result, isn't it? Can I say that if I get toss first, the next one would be head only? No, I cannot. So those are independent events. But what if there are some cases in our life or in our normal lifestyle where we can say that if first thing happens, the next thing chance of happening will be very less. For example, recently, in Indore only one question is there. I just wanted to give a normal example, but it is not possible. In Indore question, they said that the chance of hitting a target hitting question is there. In the first event is 1 by 10. What is the chance of A hitting before B? Okay, what is the chance of A hitting before B? In this probability. So those are condition probability. That means if A hits the target, B should not hit the target. B cannot hit the target before A hit the target. So I have to consider all those cases where A hits the target first before B. So till then, B has B should not hit the target. So that was the question in the recent indoor examination. You can refer that. We have that video also. Okay, so that is conditional probability. So we have to be aware of these events and be aware of these cases where the conditions, I mean, this type of questions can be asked, because in Indore and Rohtak and different BB examinations, they concentrate on these events from probability. Probability questions cannot be asked very lightly. They can be asked in these events only. So if you are good with this thing, it is okay. Okay. So different models I just want to discuss in probability were just limited to what all the models that were discussed in, that were asked in different examinations. An integer is chosen at random from the first 100 integers. What is the probability that if this number will not be divisible by 5 or 8? Okay, here we cannot just count the numbers where 5 and 8, what all integers can be, cannot be divisible by 5 and 8. We can easily say how many integers are divisible by 5 and 8. Okay, we should not select that type of number where this 5 and 8 should 5 and 8 can divide that. So I should select only these two things, right? Either 5 or 8, divisible by 5 or 8. So the important thing here is not 5 and 8 but or. You know why? Because if I say 5 and 8, what should we do? We have to take LCM for 5 and 8. So LCM for 5 and 8, they are co-prime, so the answer is 40. So we have to check for divisible by the numbers which are divisible by 40, not 5 or 8. So here it is said or 8, that means I have to select those numbers which are 5, which are divisible by 5, those numbers which are divisible by 8, and those numbers which are divisible by 40 also. Oh, okay, fine. How many numbers are divisible by 5 less than 100? That would be 20. 8, it would be 12. Okay, 8 12 96, right? So about 40, they are 2. So here in this 5 or 8, in this total 32 numbers, do I have the numbers which are divisible by 40? That is 40 and 8. Do I have these two numbers? Do I get the two numbers in this thing? Yes, I counted twice. So I'll remove that from here. 32 minus 2, that would be 30. So 30 numbers should not be selected. The integer chosen at random from the first 100 integers, what is the probability that this number will not be divisible by 5 or 8? If they ask what is the probability of selecting by those numbers, number divisible by 5 or 8, I can say it is 30 by 100. 30 by 100 will be getting by 30 C1 by 100 C1. Okay, but they said number should not be divisible by them. That means 1 minus 30 by 100, that would be 70 by 100. Okay, that means total events minus the required event, non-required event would give us the required event. Okay, so in this way we can find this answer for this model. Okay, so whenever you find any difficulty in finding or counting number of numbers, recently in the recent Indore question also, they have asked a question about how many numbers are there which are divided by both 4 and 12, I think, something. So which number is there? So again we have to set, okay, let it be. So some numbers are there which are divisible by 40, some condition is given, so that condition has to be satisfied in this. If you cannot count those numbers, you can count which numbers are not divided by that, and you can remove that from the total. That is 1. That is the probability that you can easily say. Okay, so these type of problems are very easy. Okay, yeah, this is what I am talking about. This is the conditional probability. A husband and wife appear in an interview for 2 vacancies for the same post. The probability of husband selection is 1 by 7 and that of wife selection is 1 by 5. What is the probability that one of them will be selected? Okay, so here the case is there are 2 vacancies, both can get selected, but they are giving a condition that the probability that one of them will be selected. That means if one person gets selected, other person should not be selected. Okay, so if let's draw the diagram here, not diagram, the plan. If husband gets selected, wife should not get selected. Okay, but it is not only male oriented, it's also female oriented. They say that, or wife can get selected or husband should not get selected. This is the only thing we require. So what is the probability of husband getting selected? It is 1 by 7. Then wife should not get selected. Okay, that is a compulsory condition. So whenever we need compulsory condition, we have to multiply that. So 1 by 7 into what is the probability of a wife not getting selected? It is 1 minus 1 by 5. The previous problem, just we have done that. So it will be 4 by 5. So 4 by 5 plus wife getting selected, 1 by 5 into what is the probability of husband not getting selected? It is 1 minus 1 by 7, that is 6 by 7. So into 6 by 7. So the answer would be 4 by 35 plus 6 by 35. So 10 by 35, that is 2 by 7 will be the probability of any one of them getting selected in this interview. Okay, so this is condition probability. If husband gets selected, wife should not get selected. Or see, another condition can also be possible. Whenever a condition, a possible condition is there, we have to add that to the remaining probability. If wife gets selected, husband should not get selected. Okay, what if the question is like this? Both getting selected. That means 1 by 7 into 1 by 5. Both has to be get selected, right? Because there is no condition that if wife selects, husband should not get selected, like that. So 1 by 35 will be the answer for that. Okay. Let's go to the next one. A box contains 2 tennis, 3 cricket and 4 squash balls. 3 balls are drawn in succession with replacement. Find the probability that all are cricket balls. So the important point here in this question is not cricket balls, tennis balls or squash balls. It's with replacement. Okay. So let's see this one. Find the probability that all are cricket balls. How many balls are selected? 3 balls are selected. Now, if I have to select 3 balls from 2 plus 3 plus 4, that means 9 balls. 9C3 would be my sample space. So among this thing, what will be my chance of getting cricket balls only? It would be 3C3, right? This is with replacement. With replacement means if I draw one ball, okay, fine. Let's explain this. So let us draw one ball. If I draw one ball out of this thing, it would be 9C1 out of 3C1. Okay, into again. Can I, if it is replaced, that means if I throw that ball again, so it would be 3C1 into 9C1. The total balls will be same. And again 3C1 into 9C1. So total I got 3 balls which are all are cricket balls. But what if it is said without replacement? Okay, what if it is without replacement? That means if I take one ball out, how many balls will be there in total? For the next ball to take, it would be 8. Okay, so 9C1, 3C1 divided by 9C1 would be the first probability, getting first ball as in cricket ball. Next, how many balls are there in the next row? It will be 8C1. So among 8 balls, now I am drawing one ball. That would be, how many cricket balls will be there? 2C1. And next one, and for the next one, I am not replacing it. I am not throwing that ball again. It would be 7C1 into 1C1. Okay, like this 3 by 9, 2 by 8, 1 by 7, they should be multiplied because everything has to be multiplied. They are compulsory. Okay, this is for without replacement. Whenever they say, like all 3 balls are taken at a time, I can say it is 3C3 divided by 9C3. Okay, that is for that. So this is the condition for, this is the way to solve these problems. So we have to be very aware of this word, with replacement or without replacement. Okay, so yes guys, this is all about quantitative aptitude or higher math questions that can be asked in IIM Kozhikode. Not only IIM Kozhikode, your IIM Bangalore exam also. So here we concentrated only on types of questions and types of models which can be asked, which are more asked in different types of examinations till now in BBA entrance examination. So I'm not saying here these are the only models you have to concentrate, but whenever you concentrate, whenever you see this topics you prepare for these topics, please concentrate on these models more, because these models are very repetitive and more scoring, and there is a more probability for you guys to mark them as wrong. Okay, thank you guys, thank you for your patience, and thank you for your support. Till now we have done IIM Kozhikode's videos. We are planning for the next next projects as well, so we are going to communicate and connect with you guys in future also. Thank you guys, please like, share and subscribe our channel. Thank you.